Thank you all so much for joining us. It means the world to have our friends in the data analytics community come out together. And I have to be honest with you all, I'm really excited about this particular event, and I do think that it will be worth the wait. So without further ado, I want to get started and explain a little bit about what ADE-bench is, how it got created, before passing it off. Alrighty, so introducing ADE-bench, the Analytics and Data Engineering webinar. I'm Jason Gans. I'm the Director of Developer Experience and AI at DBT Labs, and I am thrilled to welcome with us today our featured speaker, Benn Stancil, founder of Mode, poet laureate of the modern data stack, creator of ADE-bench, and general cool guy and fashion enthusiast. So here's what we're going to be talking about today. Benn has created a benchmark called ADE-bench for measuring how good AI agents are at doing analytics and data engineering work. I'm going to give you a quick welcome and background on why we at DBT Labs think that this is a foundationally important benchmark for understanding how models help data work. Then Benn is going to go and give us a walkthrough of ADE-bench. That's going to be the majority of the session, and Benn has some cool results to share with us. And it's a very interesting project on a number of levels, technically and showing off how the models are at doing analytics work. Then I want to return and quickly ground what this means for all of you, because we are going to be getting kind of into the weeds about what this benchmark is and how it works. But I want to convince each and every one of you that the results of this benchmark and the way it is built is important for understanding where data work is going to go over the coming years. And then finally, we want to leave plenty of time for Q&A. There's a lot to talk through here. Honestly, we could probably do multiple hours of Q&A, but we'll start with 20 minutes, and then we will give you plenty of information about how to keep the conversation going. Okay, so you have likely heard many times about how coding agents are reshaping software engineering. We have seen the rise of Cursor, of Claude Code, of OpenAI Codex, of Gemini CLI. Everyone that is working in software engineering, at the beginning, it's been so funny because at the beginning of the year, the question was, are LLMs and agents useful for software engineering? And pretty quickly this year, we have passed that from these things are useful, they are very useful, but how exactly they are useful and what exactly they are good at is still something that we don't exactly know. One thing that we do know is that benchmarks are key to measuring the quality of coding agents. So there's a number of high quality benchmarks that are used for coding agents that every time you see a new model release, the model providers will explain, oh, on Software Engineer Bench, which is the biggest one, but there's dozens, this new model improved. And so what benchmarks do is they are rigorous ways to measure how good a model is at performing a specific task. They allow you to evaluate over time the progression of models. They're not perfect, and we're going to get into some of their limitations, but a benchmark is the best way that we have today of saying, okay, over time, how good are models at doing these specific activities? So one of the key philosophies of DBT and analytics engineering is that the lessons of software engineering are critical to understand for data work. And so over the next several years, we know that coding agents are going to reshape software engineering. And what that also means is they're going to reshape analytics and data engineering. But the key thing is we don't know exactly how this is going to go. We don't know how fast. We don't know what tasks they're good at. Right now, data teams are kind of operating blind about how good these models are at actually performing the tasks that you all do every single day. Because analytics and data engineering, are kind of like software engineering. And so many of the same problems that are being solved that are allowing the models to get much better at bench and the other coding benchmarks, those are covered, and those make them better at doing data work. But there's also many data specific challenges. And this was something that I noticed earlier this year. I wrote a newsletter where I had tried Claude Code on building a DBT project. And in many ways, I was stunned at how good it was at building a DBT project and understanding your data. At the same time, it kept making what seemed to me simple and obvious mistakes. And the reason for that is because we simply hadn't tuned it to work specifically well for analytics engineering and data engineering work. And so if coding agents are coming to data work, which we know that they are, and if benchmarks are a best way of measuring how good a model is at doing data work, then we need benchmarks for analytics and data engineering. And that is where ADE-bench comes in. So in just a second, I'm going to pass this off to Ben, who's going to tell you about ADE-bench, the benchmark he developed. But I want to talk about who this is for and why this matters. For the data and AI community, for the people that are interested in building open source projects, in moving ahead the future of how data work is done, ADE-bench is going to be a canvas to allow you to contribute and to allow you to help us collectively understand how good the models are at doing this work. If you're someone that's more interested in figuring out how to deploy agents in your own organization, whether you're a data leader, whether you're a data engineer, the lessons from ADE-bench can help you understand specifically and tactically what you can do to make your agents actually perform well. And then for everyone involved in the industry, it's important that we have a sense of what these models are good at and what they're bad at, so that we can build systems that allow us to deploy models safely and securely. And with that, I would like to welcome to the stage Ben, and he is going to introduce us to ADE-bench.
All right. This works. Cool. Okay. Let me attempt to share my screen here. All right. Amazing. Cool. All right. Thanks, Gans. Okay, so I want to run through some of the stuff that Gans was talking about. Basically, a little bit of where this came from. There's going to be some background on what exactly it is, and then a demo, and then we can get to the results and some questions. So as Gans said, I am Ben. We're going to talk through what ADE-bench is. Before getting into that, a big special thanks to DBT Labs and Gans for making this project possible. There's a lot of contributions from folks there to make this work, as well as the folks from the Macro team. If you haven't checked it out, they're building some AI products to help people solve exactly these problems, and they were big contributors to this as well. So shout out to both DBT and Macro for this. Also, you can just go to dbt.com now. I didn't know this when I was putting this together, but it turns out dbt.com works as well as getdbt.com, so that's cool. Also, thanks to these are the two kind of, I'd say, original projects that a lot of this was built on top of. There's a lot of benchmarks that are out there. Spider 2 is one of the early kind of like text to SQL types of benchmarks that a lot of their work was stuff that we used here, as well as Terminal Bench, which provided kind of the framework for how to build these things. They built a very popular benchmark for asking agents to solve problems in a terminal. And so these four folks are big contributors here, even though I'm the person up here giving this presentation. All right, so as Gan said, so I prior to a lot of this was the founder of a company called Mode. As a founder, a lot of the job that you do is actually being like a sales rep. And so what that means is I gave a lot of demos. And when you give a demo of like an analytics project, especially a project for like analysts to solve problems or data engineers to solve problems, there are two things that are kind of consistent with these demos. One is whenever you give demos, you always say that your Wi-Fi is bad at the beginning of it. So then if like stuff goes wrong, you can be, oh, it's my flaky Wi-Fi. And you can say like, that's the problem with the live demo. It's not the project, it's the Wi-Fi. The second thing is every demo kind of follows the same script for analytics projects. They basically start like this. You like look at a chart, you see some numbers and stuff. You point out some like weird blip in it. You're like, oh my God, why is this thing down? You write a bunch of SQL queries and you go through and do a bunch of fancy analysis. You pull up some tables that say like find some bit of insight, then you publish this great report that says like, here's the thing that we need to change, and your bad like business goes into a good business and everybody's super happy. And it's always these kind of like very tight, well-structured problems where everything is neat and clean, and you find this like amazing needle in the haystack that like solves your business problem. And for most of the people here, I'm sure you know, like this is not actually how most of this work really works. Typically, you are, instead of looking at dashboards with this like amazing little like, what is this weird outlier? You look at very broken looking dashboards like this, or dashboards like this that don't really say anything, or dashboards that look like this, where there's just a thing that is broken, and the actual problem you have is your boss reaches out to you and says it's broken, and like that's kind of the extent of what we do. And then we have to go into this sort of project and be like, what's broken? And that's really our job. It's not to go find like these amazing insights so much as it is to like, stuff's broken, we got to go fix it. And so as Gan said, like software engineers can do this now with very fancy AI tools. At Microsoft, 30%, whether or not these numbers are exactly right or not, up in the air, these could be very heavily disputed, but still people are saying like AI is writing a lot of code, doing it at Salesforce, doing it at Google, stuff like that. And so kind of the obvious question for us as analysts is, hey, like, can we have one of these too? Where we don't have to go in and go spelunking through all of these enormous like code bases to figure out what is broken because our boss is yelling. And so there are people trying to solve this problem. The folks at Hex are building analyst agents to be able to do this. The folks at ThoughtSpot, which I used to work at, doing the same thing. There are some other startups like Julius that are trying to solve this, and a number of others. And so like part of our answer to that is like, good luck. We're all counting on you to do this, so we don't have to do this work. But the real answer to like, can we have one? Like, are there things that can solve our problems for us and do a lot of this like difficult and often tedious analytics engineering or analyst work? Is like, we don't know. That we're not actually sure if these things work or not. That everybody like individually at their companies might have things that work quite well, but broadly, we don't have a great sense of how well these things can solve these kind of data problems. Because as Gan mentioned, within these benchmarks that most of the major model providers provide, there aren't that many that are looking at data tasks that are representative of the things that we do. This is the benchmarks that Claude released when they put out Claude Opus 4.5. None of the ones on here are related to data tasks. Similarly, this is when Gemini 3 came out. This is their benchmarks, and there's nothing on here related to data tasks. This is GPT-5, I think. They put out a bunch of benchmarks for that, and also there's nothing on data tasks. And so, like, until we have something that helps us say these things are good or not at solving these problems, again, we're kind of like, we'll use the tools that are out there, but everybody has to do it individually, and we don't have a great sense of what works and what doesn't, and we're all kind of like groping in the dark to try to figure out how to make these things solve our problems. So as I said, there are some existing benchmarks that are attempting to help do this. Spider, which I mentioned earlier, is one of the big ones. They have a bunch of like text to SQL problems. But the thing is, a lot of these problems are structured like this. They have these kind of very basic sets of data where it's like an orders table and a customers table and a products table. And then they will ask questions like, what is the most popular product in California? Like, these are kind of like okay, can you combine a handful of tables to answer some question? And it's a very helpful, like the work that they have done has been tremendously helpful to figure out how well these things can write SQL and things like that. But again, this isn't that representative of the types of like business problems that most people are trying to apply. In reality, we have, again, projects like this and things saying like, it's broken. And so really that's kind of the foundation of what we're trying to create here is, can we build a set of tools or a set of problems that are representative of this, that are, here's a giant project, it's broken, and like, can an agent figure that out? And how well do they do in different problems that are structured like this? So that's what ADE-bench really is it's trying to be as much of a real world representation of the types of work that we do, the kind of messy things where you have projects with hundreds of tables and often like bunch of tables that could conceivably be customers and things like that, as opposed to there being these very tight schemas that are designed to be kind of toy problems for AI to figure out. So that is what ADE-bench is. I want to walk through a little bit more specifically of like the technical details of what it is. I'm going to give a quick demo and share some of the initial results, and then we can talk about how people can help and get in the Q&A towards the end. So what is it? This is going to run through a little bit more of like the technical structure of how it works. It is like a stylistic introduction to what it is. This isn't all of the details, and it's designed to be a little bit more comprehensible, but this is basically the basic framework of what ADE-bench is and how all the components work. So at its core, it is a set of DBT projects. So every task has a DBT project associated with it. So in this case, for instance, if you have like a project like a Jaffa project, it would have all of the things that you would expect in a DBT project. Like it's got the models, it's got macros, it's got some of the configuration files. all of those sorts of things. So it's basically just saying, hey, this is a DBT project that is designed to be representative of what you would have in the real world. There are also databases. So the other part that is a major component of this is you have to have actual data. There's a lot of problems that we have to solve that aren't just in the DBT project itself. It will be things like the data itself is broken, or the data types don't match, and things like that. And these aren't things that we will actually be able to discover in the project or the project files. You have to look at the underlying data to solve it. So ADE-bench includes databases. If you open up one of these databases, if you open up a DuckDB database, it looks like nonsense. But if you open it up in like kind of a fancy way, it's basically just a collection of tables. It's essentially a bunch of Parquet files that you can read with DuckDB. And you can open up all these tables and see what this data is. So it's a way for us to be able to share, be able to like take the projects, and then you have data to run those projects on top of. And then the third major component of ADE-bench is the tasks themselves. These are the problems that are designed to be solved by an agent. So you've got, for instance, say you've got like Joffel 001. That is the task. The task will have sort of variants that define which projects and which databases to read from. So in this case, it's saying, hey, this task is on top of the Joffel project, on top of the Joffel database. Great, this is just configuration. And then there is an assignment. There is basically something that you give to the agent to say, hey, go solve this. In this case, you could be like, it's broken. Something here is wrong in this thing. This is maybe what like an executive says to some Slack bot that says, hey, my data is broken. Can you solve this problem? And so once you have this, once you like specify these projects, if you run ADE-bench, so you can just run run Joffel 001 to run that task. What will happen is ADE-bench will spin up a container. It will basically create a sandbox environment for us to try to solve this. It will stick the DBT project in that container. It will stick the database in that container. It will stick a bunch of technical miscellany in that container, which I will describe in a moment. And then it will say, hey, Claude, or whatever agent of your choosing that you've decided to try to run. It will say, hey, is broken. Like, here's the task. Go solve this thing that we need you to solve. Then ADE-bench will basically let the agent run, do its thing. So Claude Code or the Gemini or Codex or whatever like command line tools you want to have to go solve it can go try to solve it. It will go off into the wilderness and try to figure out what's wrong. It will bring back its solution to the benchmark. The agent will sort of exit the sandbox, and then we will test to see if it works. And so that's the second part of the tasks is there are tests that are designed to evaluate whether or not the agent did the thing right. These things currently are mostly DBT tests. DBT tests are like a useful framework to be able to just evaluate whether or not the thing did what we wanted it to do. They don't have to be, but like for right now, most of them are just structured as DBT tests because it's a useful sort of vehicle for running tests in a project to see if things change the way we wanted to change. These tests can be arbitrary. They can be kind of whatever you want. You could have things like, hey, did it figure out the right number of total orders? Like if I asked it to create an orders total, like a total orders table, does that total orders table have the right metrics in it? So in this case, be like, hey, was if we asked it to solve this problem, did it return a table that had said that total orders were correct? Was it 295 and that's the right answer or whatever? So it's basically a way to specify what the right answers are. You can also do things where it's like you say you want to ask the agent to change things from like a materialized table to a view or anything where you want to like inspect the actual SQL inside of the updates that the agent has made. You can use some of the DBT macro frameworks to be able to inspect things in this way. You can basically inspect a lot of the stuff that the agent does that isn't just a SQL query, but in this case, you can check to say like, hey, is this materialization correct if that is the project or the task that you want to give the agent. There's also some other like automatically generated tests if you want to use them. Suppose you want to just compare a model that the agent generated to the like a answer key. So say you want to say create a fact orders table. Can you compare the solution that the agent generated to like an answer key? There are ways to automatically generate these sorts of tests where you provide basically a seed project, a seed CSV to say, hey, this is the correct answer. Can the agent create something that matches this correct answer? And so in this case, it would say, hey, the fact orders table that the agent creates, does that compare like favorably to the solution that we give it? And then there is a seed project that you can, or a seed directory that you can provide to put that like answer key in it. And then the ADE-bench will basically handle all of this equality to say like, hey, this thing produced the right thing that correctly answers the question. And that allows you to not have to do some of these weird specifications where you're things like, I need to define what the sum of the total orders is in the fact orders table or whatever. You can basically just say, hey, here's the answer key. And if that answer key is correct and matches the thing the agent does, then the test will evaluate as correct. So there's a couple other sort of pieces of this, which is if you want to run arbitrary scripts before or after the agent does its thing, you can also do that. These can be very helpful to do just some sort of like environment setup. If you want to run things like dbt deps or dbt run to create sort of broken environments, you can do that. You can also explicitly inject problems into dbt projects. So say you want to break something, you want to like remove a comma or delete an intermediate model or introduce some sort of chaos into the dbt project that is, again, somewhat representative of the way that we actually have to work. You can create scripts that do those sorts of things to the project before the agent gets it. So if you have like a fully functioning and dbt project that all works the way you want, you can start to introduce little bits of chaos to make the agent have to solve something that's harder than what you might imagine. So in this case, you could have a script that says break fact orders that just like removes the comma, and now the project is broken, and now you have to actually fix that. You can also just things like remove entire models and then tell the agent to recreate this model. Say you want to have like you have a stats model or something that is the final conclusion of a project. You can basically say, hey, remove that. And now the agent's job is to create that, and it won't be aware of what that prior model was. So in this case, if you run something like this, then you can get rid of the model and ask the agent to solve that problem. So what does that look like all kind of packaged together? This is, again, the basic sort of stylistic structure. If you run ADE-run this Shuffle task, what it will do is, again, create a container with all of these things in it. It will run the setup scripts to say like, hey, break the project by removing a comma or doing whatever thing that you want it to do. Run dbt. That will now execute dbt in the sandbox, and it'll run some errors because there's some stuff that's missing. We will then hand that to the agent, say, hey, Claude, it's broken. Let it go do its thing. Once it exits and says, I'm done with the thing, it will then take the solution, stick it into the project and say like, run dbt seed with this solution, and then compare that solution to the thing that the agent did. And again, these are all like fairly configurable in whatever way you want, but this is kind of the basic core of it to say like, hey, break the project or find a project that's already broken or find a project that's not broken and ask it to add some update, run the agent, and then evaluate it with these tests. So what will happen, typically one of three things will happen when this runs. One, the agent may just completely get it wrong and fail to actually update anything, and dbt doesn't compile or it like leaves errors in place. In those cases, the first thing that the evaluation suite will do is making sure that like dbt can run correctly. If it can't, then the task will fail. In some cases, dbt will compile just fine, but then like these tests that you write don't actually work. So say, for instance, that like the fact orders table that the agent created is not the one that you wanted to create. The test will then fail for not having those matched orders. Or in the cases that it all matches, then great, then the task passed. And so what we've done is created a bunch of these, and you can run all of these things in succession and see like, hey, how do the agents do against a whole suite of tasks that are all like representative of the types of things that we do. Okay, before getting to the demo, I want to go through a little bit of the kind of technical miscellany of how this works. There's a handful of things here that are like different ways you can adapt it or different things that can help people set stuff up. I'll run through that and then I'll give you some of the scores. So first, agents themselves, like what are these things? What are we actually doing here? What are the AI bots that we're asking it to do? You could configure different ones. So currently it's set up to support Gemini and Codex, and which is OpenAI's like Claude Code competitor, and Claude itself. So when you run this, you can specify an agent. So you can say like, okay, I want to run this with Claude, or I want to run this with Codex. And in those cases, basically, it will just say, hey, like give this prompt to the correct agent. So it'll essentially change, instead of running Claude, it's broken, it'll run Codex, it's broken. And then the ADE-bench kind of handles all the environment setup to make sure that these things are correct. You can also specify individual models if you want. So if you want to see how it does with like Opus 4.5 versus Haiku, you can run different models against it as well, and we'll show some of the results for that in a moment. So you can do like, or Gemini, and does the same thing. So that's pretty straightforward. Second thing is dbt fusion. So folks here may be familiar with this. dbt fusion is the new dbt. So right now it supports both dbt and dbt fusion. If you want to run a project with dbt fusion, you can do that as well. In this task definition, there are variants. You can say, hey, this project type is dbt on top of duckdb. If you wanted to, so what that does is the technical miscellany it injects is it's like running dbt core inside of the sandbox. If you wanted to instead say like run on dbt fusion, then when you can specify that with the same sorts of flags, then it will pip install. This isn't actually how you install dbt fusion. That's very stylistic. But the idea is if you want to use sort of different dbt setups to run these tasks, you can do that as well. And similarly if you want to use like dbt's MCP server or those sorts of things, that's all possible in this too. That's not in this presentation exactly, but some of the demos will show using MCP. So you can configure sort of the dbt environments in the way that you might want to as well. Some of you may be skeptical, be like, wait a minute, this is running dbt fusion on top of DuckDB. Like, that doesn't work. How do you actually run dbt fusion on DuckDB? You can't. dbt fusion is not supported with that. So the other thing you can do there is you can also configure different types of databases to run. So right now, this is again specified to run on DuckDB. If you want to, you can run it on Snowflake. And so this will, instead of running on top of a DuckDB environment, it'll run on top of a Snowflake environment. You may also be skeptical of that and be like, there is no such thing as like Joffle.snowflake. How in the world does that work? So I want to talk a little bit more about databases. So basically, like, this supports the ability to run these things on top of different types of databases. There's also, you can add a flag for running it on Snowflake or DuckDB. When you run it on top of Snowflake, what it will do is it will, if you have a Snowflake instance connected, it will basically create a sandbox within Snowflake for the agent to run. So it will create a sandbox database within your Snowflake account for that project. It will then create a user that has access to that project. It will grant the right permissions to that user and give that user to the agent and let the agent operate in that way. Generally, and the docs have a lot of this, like, we don't encourage you doing this again sort of directly against your stuff, because you are giving an agent somewhat access to your database. It is giving it in a very sandboxed way. We can talk about that a little bit more if folks have questions, but the point here is give the agent a sort of sandbox to play around with in Snowflake that is representative of exactly what the thing would have if it was actually doing this in a production environment. And so also the harness will handle basically all of the configuration for this as well. Sometimes you will also need to have like various permissions and things like that. This will basically set those things up correctly. It will update things like the DBT profiles YAML file to be correctly configured for these sorts of things. No, you still may be skeptical of some pieces of this. You may be like, hey, wait a minute. You can't just like copy a database from DuckDB into Snowflake. How does that even work? There is a way to do that. So basically it has some utilities for you to migrate things from DuckDB to Snowflake, where it will take the DuckDB files and put them in the correct place in a Snowflake database if you have it connected. And you may have one final bit of skepticism, which is like, you can't actually run DuckDB queries against Snowflake queries. Like, those things are inconsistent. And so there's ways to have migrations as well, so that if you want to say like, hey, here's a DBT project that works against DuckDB, you want to migrate some of the functions and stuff like that to make it more functional against Snowflake, you could do that as well. This is pretty helpful if you have smaller projects. I would not encourage this if you have very large projects, because you're not going to necessarily want to do that. But if you have smaller projects that only have a handful of things that need to be migrated, these scripts allow you to run it against these different environments, which is pretty useful. Like, what's the point of all this? There's a lot of complexity here. Like, why do all of this? Basically, the thing we're trying to do here is to create these very realistic testing environments, which requires us to have these like large DBT projects. We want to be able to do it with fairly complex evaluation criteria. These can't just be like, how many shirts did we sell on Tuesday? They need to be, sometimes it's like create 4 or 5 models. Sometimes the output of these models is very large. Sometimes they're sort of arbitrarily complex things you want to evaluate. And so using sort of arbitrary SQL queries to evaluate it allows us to do that. We want to be able to do it in a way that can be shared through simple files. The reason a lot of this is built on this on top of DuckDB is because it allows us to basically just share data with people to be able to run these themselves. Putting it in, it's a very simple way to basically hand databases back and forth. Also can run very quickly. But things like migrating into Snowflake are important, because that's probably what most of us have as production environments or Snowflake-like things. Most of us are probably not running production warehouses in DuckDB. And so being able to see how it actually runs in an environment like Snowflake is a very helpful thing to be like, how does this actually work in the real world? And then you also want to make it easy to create tasks. Part of the point of like these setup scripts and things like that is you can have a DBT project. You can run a bunch of different tests against that individual project, because you can have it sort of modify the project on a task-by-task basis to let you create like Joffle 002 and 03 and 04 and so on, that allow you to say, hey, in this case, delete this model. In this case, like, introduce the chaos in this way. In this case, like, don't do anything and ask it to add new stuff that it doesn't already see. So essentially, it's trying to build a way for us to build as many of these tasks as we can, while also being able to maintain kind of a central repository of projects and databases that allow us to be able to have a framework to build it on top of. Okay, the last thing before the results of the demo, there's technical miscellanea. I want to have one kind of small bit of philosophical miscellanea, which is analytics tasks. This is a thing that a lot of people have asked about, is like, a lot of the work that we do is by nature subjective. Like, if we see this and our boss is like, it's broken, there's not exactly a correct answer to what that means. It's not like he's asking for some number. The boss is asking for like, tell me what might be wrong, and there may be 3 or 4 things that are appropriate there. How do we evaluate that? Most of the tasks currently are focused on more like analytics and data engineering problems. However, there are some that are these sort of more analytical questions. The way that we have currently done this, and this is something for projects for a future date or like stuff to extend, but one of the ways to do this is you could actually do this through things like this. So this is an example of a project or a task that I can actually show you in the demo. Basically, it's asking for like, hey, there's something that have happened where I want to know the answer to this question. Can you help me figure this out? I created this new table that I think will solve it. Which of these followings is a problem with this analysis? And it's basically a multiple choice. And then it says like, hey, include all the answers that are correct. The point here is like, you could dispute whether or not like, is A way more correct than B or whatever. These things should be set up in such a way that there's like not necessarily one analyst may say it's A, one analyst may say B. The correct answer could be like include A and B. I think that's appropriate. But the point of a lot of this is, for the same reason that like standardized tests work, the better you do on a standardized test, the point is like, does it correlate with success? That's really what we're after here. We're not trying to say like, what is the definitive answer to what we should do? The point is, if agents get better at answering those sorts of questions, that is a sign that they are getting better at being analysts to do these sorts of jobs. It doesn't mean that these are like exactly real world problems in the same way that the SAT is not a real world problem of what it means to work at McKinsey or a prestigious law firm. The point is, the test actually does a decent job of correlating with your success of these other things. And so we're trying to create environments that allow us to say, hey, how do these agents do, and do they correlate with the right stuff? And so I think in these cases, like some of these open-ended questions, the point is not to figure out some like, what is the philosophical way to solve an open-ended question? It's more, hey, can we give it problems such that if it improves on answering these questions, we can confidently say it would improve on answering open-ended questions in a real-world environment. Okay, so last thing I want to go through here is, or next last thing is like some of the results in the demo. The results here highlight, these are like initial results. This is stuff that obviously is going to evolve over time and stuff like that. And we want more people to run them and confirm that we're getting the same stuff and things like that. But this is kind of where we are with the stuff we've created. So this is what happens if you run Codex, which is OpenAI's model. This is all using GPT 5.1 Codex, which is their specific one designed slightly for Codex. It passes like 56% of the tests. I would not consider the 56% here to be meaningful. The point is like a baseline of how well do things do relative to one another. It's like when you put out the SAT for the first time, what does it mean if you get a 600? Nobody knows. Like the point is, how well does that score? How well do you rank against everybody else? So the pass rate is a pretty tunable thing. You can just make the problems harder or remove the easy ones and change that. The point is, how do these things do against the same set of tests when you have different agents or configurations? So this is how Codex does. Gemini basically is expensive, and they have a lot of like API restrictions. If you work for Google and you want to give me some API keys for Gemini to make this more functional, great. Otherwise, it's a pain. But basically, Gemini largely does roughly the same as some of these other things. The reason this is a question is like, I want to be sort of fair with the way we do these scores and the way that the Gemini tests have worked. The scores aren't actually comparable, but it's broadly similar to the other models, except considerably more expensive. Sonnet 4.5, which is kind of the core Claude code model, if you don't specify anything special, and kind of the workhorse model for Claude, does almost identical to Codex. It was actually interesting, the precision to which they are actually the same. They basically have the exact same pass rate. They cost almost exactly the same. So shout out Codex and Claude Code for basically delivering the exact same result. But you may be just asking like, okay, how does this do against different DBT setups? So I wanted to basically compare. These are kind of the core things on top of DuckDB. What happens when you change it to different setups, including Snowflake, which actually adds a good bit of complexity, and then changing like DBT configurations as well as changing models. So Snowflake is actually a little bit harder than DuckDB. This kind of makes sense because the agent doesn't actually have access to the underlying data itself. It can't run queries as quickly. It's having to wait more for queries to return as opposed to just like running it locally, which is much faster. So like if we sort of the benchmark to me is these like basically 50% that, so the test as they're set up in Snowflake solves about 50% of the tests for about $13. If you give it DBT plus MCP, so if you give it DBT core with MCP server, it improves to 54%. So MCP servers do seem to help here, specifically the DBT one. If you use Fusion, the pass rate goes up a good bit. This also makes some sense. It's able to actually do a lot more interacting with the data. There's like a lot faster ways for the agent to check if things compile and things like that. And so it's going to be a little bit smarter about how it does things and a little bit more like rigorous in how it tries to solve stuff. You can see that in the run times, like it actually spends a little bit more work doing this, but it actually solves at a higher rate. And similarly, if you add MCPs on top of Fusion, you get kind of the combined benefits. The pass rate doesn't go up, but it is faster. So it kind of, again, this kind of makes sense. It's able to basically do some of its work faster. It's able to be a little bit smarter, probably mostly because of the Fusion work. And so that's basically the best combination here is using both. Fusion seems to be the biggest gains in pass rates, and the MCP server seems to provide the biggest gains in like efficiency. But the combination of those two does help the agent solve these problems a good bit more. The other thing I want to look at was how do different models differ? So one is like a kind of scoring benchmark is how does it do with an old model? And the answer is not good. If you give it Haiku 3, which is the really old like stuff, I mean, it's really old. It's like, what, a year and a half old or something. It only solves 10% of the things, which is great. It also means that this thing works okay. And then we're not giving it like tests that everything can solve. So the old models don't actually solve too much. Haiku 4.5, which is Claude's like fast, cheap model that is the most recent one. The pass rate goes up a good bit, but it's still a lot lower than the more expensive models. And Opus actually gets about the same as Sonnet 4.5. Part of this seems to be that the thinking models tend to spiral a little bit. They tend to kind of oversolve some things from poking around the answers. You could also see that in the total cost. Part of that is, I mean, Opus is more expensive, but if you look at like the number of turns that it actually takes, there's the number of sort of like requests that it makes. Opus tends to do a little bit more, and I think in some cases, like trying to be efficient actually helps the model solve these things a little bit better. And similarly, what happens if you give Codex Fusion and MCP on top of Snowflake? It actually doesn't really improve that much. So in this case, I think this is basically resolving at the same rate as Sonnet 4.5. So again, the best things here seem to be providing Fusion, providing MCPs. And then the more expensive models do work a little bit better, but often they're more expensive. And so Sonnet 4.5 is actually pretty good. Okay, so that's kind of the early stuff. Happy to answer questions about this, but before we get into that, I want to show a quick demo of what this works. We'll see if this works. My Wi-Fi has been flaky, so we'll find out. We'll see if this actually goes. All right, let's do this. We're gonna share everything. Amazing. Okay. So let's see. So if we wanted to go here, we can see like, let's go. Okay. So we can look at ADE-bench is just a command line tool. If you want to look at the things you can do, we can run ADE help, and here's a bunch of the stuff that we can do. This is all the fanciness. If you want to like look at the tasks, so we can say ADE view tasks. And here are the tasks that have configured. There's a giant list of the things that we can actually run, whether or not they're ready or not, sort of their development state and those sorts of things. This is all like sort of the management of actually getting it to work. But if we want to run something and see how this actually goes when we run it, let's run a very simple task on DuckDB. DBT, and we'll run the Sage agent, which is basically the answer key. This always should get it right. Basically, it is the agent is just executing a script that is like the answer. It is saying, hey, this is a project. This is the problem that we have for the project to solve. And the Sage is like a script that says, here's the right thing to do to solve it. But you can see as the agent runs, it's sort of cycling through these various steps of, okay, now it's evaluating the test script. It executed like the agent, and now it's executing basically DBT test. And then it will spit out a thing that says what happens when it runs. And it should take just a few seconds. And after, so it passed. There were 2 DBT tests in this. The 2 DBT tests passed. Great, as it should. Like, again, it didn't do anything. It just ran it exactly as we would expect. But if we want to look at the results, we can run, that opened up in the wrong tab. But we can look at the results and say, hey, this is the one task. It passed all the things. And if we want to look at the things that it did, there's a place to be like, okay, what did it do? And this task was change a model from dim customer to dimension customer. And we can look at the diff of what the agent did, which was it just updated this file name from dim customer to dimension customer to solve that problem. So this was the task. If you wanted to see that task, it says like change the dim customer model to be called dimension customer. So that's the simple version. It's more interesting, obviously, to run it with an actual proper like AI thing. So here we'll run this. This will, oh boy, what did I do? Oh, let's see. I got rid of my guy. One moment.
Live demos, folks.
Yeah, Wi-Fi is no good. Oh, I think it's here.
Ben, when's the agent going to do your demo for you?
Check out. It was in that docs thing. Yeah. I'm not here for that. Let's see. I gotta. All right. Let's see. There we go. That's what we wanted. We did need to be in that. All right. So in this case, it is running 4 tasks. This like we can have these sort of experiment sets that are just shorthands for running different tasks. I have a demo one. It's running 4 tasks: a Formula One one, an analytics engineering one, an Airbnb one, and one for against intercom data. It's now like having to set up the containers. Is it setting up the containers? It might not be setting up the containers. Live demos, Ooh, let me restart. Docker died. Docker is the bane of everyone's existence. Let's see. Let me restart this. Let's get rid of this guy. All right, Docker. Where are you at? No, see, that's what we like. All right. Chug it. There we go. Okay. Now we should be good. We'll find out. So what this is going to do is it's going to create these sandboxes, assuming Docker does what it's supposed to do. It's going to create these sandboxes, and then it will maybe create sandboxes.
Ben, while we're waiting for the sandboxes, we have a request from the chat for some Zoom.
For some Zoom?
To zoom in on the text a little bit.
Oh, sure. Yeah. So this is going to make this thing look weird, but yeah. Let's go. Well, you can't really, I can zoom in a sec. I don't know why this thing is not running this Docker stuff. Anyway, we can look at what some of these results will look like. Here's an example of what these results will look. Oh, there it goes. Okay, now it's doing its thing. All right. So here's, ignore this top table because that's from the Zoom. So it's basically setting up the Snowflake databases. In this case, we ran it against Snowflake. It's setting up the Snowflake databases with these appropriate database, the appropriate sort of environments. It runs these setup scripts, which are the things that break the project or do those sorts of things. Again, introduce the kind of whatever chaos you want. Now it is starting the agents, which is handing these things off to, in this case, the agent is Claude. In a second, you will see what it was given the agent. It says, hey, there are 8 models in this project that have this sort of problem, all those kinds of things. And now we have to wait on the agent. This takes a few minutes, and so I'm going to cut over to the presentation for a second while this runs, and then we can get into questions. But basically, this takes a few minutes to run because it's like however long the agent takes to do it. So the last thing I want to talk through real quick as we're waiting for this is if folks want to contribute. Like these are the folks who helped out a ton initially. If you would like to be involved, what can you do? There's a handful of things that would be very helpful here. One of them is contributing these sorts of tasks. The more tasks that we have, the better this is. The more things that are representative of real world problems, the better it can be. And so if you have things that you can either contribute on top of existing databases, on top of existing projects, great. If there's examples of the types of problems that you want to see if an agent can solve, contributing those tasks is very helpful. All that really is writing a configuration file. A task is mostly just, here's an example of a task. A task is mostly just, if I can zoom in, a file like this that's a prompt that is what are these solutions that you want to run, and then is like what projects and environments to run it against. Then there's like you can have a solution that it helps the Sage agent solve it, but mostly that's what a task is doing is just the setup script of how you actually want the environment to be set up, and then whatever the prompt is that you're trying to solve. So that's one way to do is contributing tasks. A second thing is contributing new projects and new databases. This is tremendously helpful because these things are sort of difficult to source. We have some utility scripts to help you be able to do this. Understanding there's a lot of like difficulty here with permissions and with what's private and those sorts of things. But there are some ways we can help solve folks with that. If you have projects that you want to be able to use or have a project that you want to put data in, we have some ideas for ways to be able to make this easier to contribute. The other thing is if you want to be able to contribute agents. So obviously, like most people here are not going to build foundational models. You're not going to contribute your own Claude code. But the way these environments are set up is you could add a bunch of additional detail within the environment to see how well an agent solves a problem. So for instance, say you want to take the prompt and add a bunch of new things like Claude.md files that actually tell the agent how to think about analytics problems. if you want to add additional context, or like, before you answer this question, go Google a bunch of stuff and then try to solve it in this way. If there's new ways that you could add sort of additional context into the problems, this is a framework for being able to test those other pieces of context to see how well you can actually improve like what a baseline agent can do without any of those pieces. So that's something we would love to see people try to do. And also you can help with the benchmark and the harness itself. So various things like what happens when it runs when a Docker container doesn't work, or when your Wi-Fi is bad. That is already on GitHub. It is available here. We would love to have folks take a look around and help us make this better and more robust as we keep adding stuff to it. We're also in there's a new DBT Slack channel called Tools ADE-bench for folks to talk about this. This is where we will live for the time being. And so please join us there if you have questions or want to contribute or be involved in some way, or just follow along. So that is basically it. I will stop things there and we'll go back here to see how well this is doing. So we got so far 3 of the 4 have passed. 3 of the 4 have completed. It has passed 2. 1 has failed. And as soon as this thing finishes running, we can take a look at what it did and look at some of the logs to see how it tried to solve these things, which is really the more interesting part. But with that, Gans, I will hand it over to you while this finishes, and then we can take a look at these results once we answer some questions.
Yeah. So thank you, Ben. At the beginning of this, we were talking about why there was no rigorous benchmark for data work to date. And I think that now you all have seen the answer, which is the number of problems that needed to be solved and the amount of foundational infrastructure that needed to get created to solve this was actually relatively high. So I'm really grateful to Ben and kind of the team of early contributors that put this together, because we now have a flexible scaffold to add new tasks, add new projects, try things. And so anyone that's watching this, there's so many different levels at which you can contribute. And I'm just very, very excited to see where this goes over the coming years. I want to talk a little bit about what we are going to be doing on the DBT side with all of you and for all of you to make these models and these agents better, because this is the story of data work over the next couple years. And so I think that there's the part of this that is going to be the changing role of the data practitioner, and the part of this that is how we build tools for all of you to enable great agents. And so the next set of unlocks for data agents on the context side is going to be teaching them how to use DBT really well, and then teaching them about your organization. So teaching them how to use DBT really well means we have a number of community-sourced agents.md, skills.md already, and going and putting these into practice on ADE-bench is going to start letting us see, okay, here's how you actually instruct the correct set of patterns into the agents to allow them to know what to do and how to do it well. And so there's a certain amount of increased success that we will be able to get on ADE-bench purely via that. And then you'll be able to port that into your organization. But if you think of an agent like an employee at your company, you're not just going to want them to know DBT really well. You're also going to want them to know context about your organization really well. And so data teams are particularly well situated to create the context that allows agents to operate on top of your data. I've been talking to a number of teams that have been kind of on the leading edge of AI and data implementation. And a lot of what they are saying is actually, it's just writing down important context about your business. What departments are there? What data sources are there? All of the things, all of the knowledge that exists in all of your head, finding ways and mechanisms to add that to your DBT project and into your agents. And so that's kind of the possibility space that we expect you all to be playing in and making a ton of progress in the near term. What we are focused on and building this out with you is also tooling. And so there's kind of two general buckets here. One is improving the DBT language framework and engine. So as Ben showed, the DBT Fusion engine provides a substantial boost in accuracy for agents due to its ability to leverage things like SQL comprehension. There's a ton more to be done there. Column level lineage, better schema information, type information. We are looking into a number of improvements kind of based off of Fusion and other things that we can add in to give the models more information. And then the other thing is better MCP tooling. So think of the MCP as kind of your entry point into connecting the agent to your dbt project. And so getting the right set of tools in there, having them organized the right way, giving the right instructions to the models for how to use them is the other thing. And so this is not something that we expect to figure out on our own. This is something that we expect to figure out in partnership with the teams actually solving this. So looking forward to having many more conversations about these and shipping you all some tools that allow you to deploy safe, effective agents that allow you to do your jobs better. And with that, I think Ben has some results for us.
Yeah, so I can quickly show you this. These are the 4 tasks. It got 2 right, 2 wrong. So here's one. This Analytics Engineering 002 is one where the task is fix the error in this DBT project. That's basically what is given the agent. The error is there is a missing comma. So if you look at what happened, it's modified a bunch of like DBT. We won't look at that. Down at the bottom, you can see it actually will just like erase a comma. Here's the solution. It added the comma back, or this is the, excuse me, this is the setup. It deleted a comma. The solution is the agent figured out there's a missing comma and it solved it. And so like good for the agent. And you can watch if you wanted to see like how it reasoned through this. You can basically see its reasoning loops here. Like, hey, I'll help you fix it. It does a bunch of stuff. It calls some tools. It starts to set some things up. It reads some things. I see there's an error in DBT run. It goes and checks some stuff, blah, blah, blah. Perfect, I found the error. And then it makes the change. Some of the ones that failed. So I think this one is included because I always think this one is kind of interesting. This is one of these multiple choice questions. Basically, this is saying, hey, there are some tables that return inconsistently. These are like top 20 lists, and there are ties at the top 20. And so like, when are the cases where there are ties that like, which table should we be concerned about where the top 20 will be inconsistent because there's somebody who's 19, 20, and 21 are all tied. And so when you run that table, it will sometimes return 2 of those 3, and we don't know which 2. And it's like, help me identify those tables that have that problem. If you look at what it did, you can see it will probably like reason through that, and it will say, hey, something is wrong. There's inconsistencies. I'm using rank, which can produce ties, which limits to 20. So I want to find places where these ties are happening. Let me look at the top 20 models. It does a whole bunch of stuff. But it ended up getting it wrong. And the reason it probably got it wrong is because some of these models have ties where there's like a tie at 18, 19, and 20. And 21st is different than 20. And so therefore, like that table will never actually get ordered inconsistently because 20 will always be the cutoff. And so this one actually doesn't explain it terribly well, but basically this problem, half the time it seems to recognize this one actually can't have a tie in the top 20 because there's no tie crossing the threshold from 20 to 21. And sometimes they're just like, there's ties around 20. That seems good enough. And so in these cases, it gets it wrong. There's another version where you can see here, like 3 drivers are tied for 19. That is correct. But here 3 drivers are tied at 18. Doesn't actually create a problem because it would be 18, 19, and 20 and no cutoff between 20 and 21. So these are the sorts of things, again, you can add all these sorts of questions like this. Sometimes it gets these one right, sometimes it doesn't. This is one of the ones that I always kind of found a little more interesting. But these are all the tests you can do. Same way. And if you run this with a full suite of them, you'll have like 40 or 50 of these that you can look at, or however many you want to add, that all can see kind of the same reasoning patterns for different agents. So with that, happy to answer any questions as well, Gans, if you've got them, or whatever folks want to talk about.
Awesome, thanks. Yeah, so we have time for a couple questions here. Let's go and see. Okay, so Robert asks, what type of data, projects, and tasks are we missing and should look to source?
Projects are the ones, like the complex ones are the ones that are hard to get. So a lot of these projects were projects that were found with Spider. The Spider 2 benchmark has a lot of DBT projects in it that are very useful. So are built on top of those. Those are more complex than a handful of CSVs, but they aren't like super messy. I think as all of us are aware, like most DBT projects are pretty messy or can get fairly messy. They have a lot of things where it's difficult to know, like, you want to know how many new accounts signed up. There's 40 tables that are called accounts that we don't actually know which one we're referring to. So projects that basically have like that level of complexity and messiness are very helpful. The types of tasks, more complex ones are always more useful than easy ones. But honestly, when I was building this, the thing that was most helpful was what kinds of tasks do you run into when you're trying to work on a DBT project? You're like, this is an annoying thing that I just have to do all the time. Let's create some examples for solving those problems. So it'd be like, as I was trying to get stuff set up, things like there was an issue with like DBT depths being broken. Okay, I'm going to turn that into a task because it's a thing I had to do that's a real world problem. So I think a lot of it is dealing with the things that you actually have to deal with as you're doing this and thinking like, should we make a task that is representative of this, as opposed to trying to like back into a toy problem. The toy problems, I think, that is not, again, what we're actually doing. We're actually doing things that typically look pretty different. And so if you find yourself trying to solve a problem in a real world thing, be like, what's the problem I'm trying to solve here? And can I create an example of this that we can ask an agent to do?
Yeah, I think one more for that is as you're reading the logs. So if you go and you run this and you see it trying to solve some problems, it might get the correct answer, but in a way that you find not fully satisfying. And so there can be tasks that are kind of inspirations of like, oh, I see what the model was going for in that one, and perhaps it may have worked in this specific case, but I actually don't think it would have worked in that case. And those are really important because a lot of what we're trying to do here is figure out what the systematic blind spots are of the model, because then that allows us to create models and systems that can cover the blind spots. Okay, we have time for probably one more question. Okay, it looks like we have some flagged questions. We got Joel asks, do you think there's a benefit to having a bunch of cloud data warehouses, or do you think we will get a long way with just DuckDB and Snowflake for this foreseeable future?
So my honest answer is that DuckDB and Snowflake and maybe like one. I think like, so if you had like a SQL Server or something that was more complex, that would be great. For the most part, agents now seem good enough that they don't mess up writing bad SQL. That like they don't struggle with the sort of syntactic quirks of writing Postgres versus Redshift versus Snowflake versus whatever. Like if they can solve it against one, they probably can solve it against the other. The database and the language is not the thing that they typically struggle with. So I don't know that it makes sense to be like, we need a Redshift version and we need a Postgres. Like if it can solve Snowflake, it can probably solve Postgres and Redshift and whatever. I don't know that that's true if you get into stuff that's weirder or has like would not be as present in its training data. And that would be the only real reason to do it. But for the most part, to me, if the point is to understand how well it can like do the reasoning of our job, I think most of that is handled by the tasks and the projects and things like that. And the database is a fair bit of complexity that isn't really necessary to decide whether or not these things are getting better or not.
Yeah. So I think if you have a burning interest and you're like, I want to add this, I want to test this on this database for whatever specific reason, absolutely go for it. But I think it's a good point, Ben, that generally the failure modes that we're going to see on this are kind of upstream of writing the correct SQL syntax, or that there are relatively foreseeable remediations that we can do to increase the accuracy for writing correct SQL syntax.
Yeah, and because these things like Claude Code and Codex will loop, like they will realize typically they wrote something bad. Like they're not one-shotting it. Here's the SQL, I hope it works. It's like they typically will test it. And so it's rare for them to get stuck on that. The other thing I would say about databases is the reason to support other ones is if that's the easiest way for folks to share it. Say it's like there's something that exists in Databricks, and we want to be able to like use that as a source data set and it only exists in Databricks. That's very helpful. But
okay, we are coming up on time here. I have I have a final message to share just in terms of next steps, and then maybe we can stick around and answer one or two more and chat a bit. But I want to make sure that folks have all the information that they need. So we will be launching a survey for the webinar. I really hope that despite the technical glitches that we all had, that you all got something out of this. We really think that this is something that will allow the data community to meaningfully improve how agents are used and enable us to reason across the different layers, the model layer, the harness layer, the prompt layer, the tooling layer, and be able to more intelligently implement this. And this is going to be something that is really important to all of our roles and to the industry over the next couple of years. So thank you all for coming out. Ben, if you will stop sharing for just a second so I can share my farewell slide. There we go. All right, so we have a QR code here, which will take you to join the DBT community Slack. You can also go to getdbt.com/community. Within there, there's the tools ADE-bench channel. We will share these links in the chat. But we have two apps for you. One is to go get the benchmark, check it out yourselves. And two is to take the State of Analytics Engineering survey. This is a survey we do every year to see how people are doing analytics engineering work. There are a number of questions on kind of like how you write your DBT projects, how your data team is structured, as well as more forward-looking things like how are you adopting AI. And so this is one of the best lenses that we have into how people are actually using and adopting that. And with that, we are officially at time. So happy to call it if anyone needs to hop off. Ben, I don't want to volunteer more of your time, but I'm happy to stick around and talk through a couple more questions. And maybe we go, five or six more and just talk through some more of these.
Yeah, for sure.
Great. Okay, cool. What's your current approach for generating dummy data for the databases? Mockaroo was the nicest tool that this person had interacted with, but wondering if there's a better alternative.
So this is hard. There are the source data right now, most of it is stuff that was provided alongside the DBT project. So they weren't like, it is dummy data, but it was dummy data that I did not generate. Sort of halfway through a process that I think we can probably get to work. One of the things that is convenient about DBT Fusion is it allows you to create a giant graph of what the project is. And through that, you can start to create like, what are the things that are basically have to exist for this entire project to run. So you can create what are the source schemas that are needed? What are the types of columns within that source schema? And probably figure out what are the relationships between those things. And so then I think it actually this is a place where just sticking it into some AI and saying, do these things, create like scripts that are like, this is what this source thing needs to look like. And now give me a script that will generate all of the source data that I need following like a set of sort of parameters to say like, these are the data types. These are the places where the columns need to be the same, or they need to be able to join. Or if it's all based on a single source, like you don't even need to do that because it's going to do the forking as the DBT project runs. So there are ways to do this. I could have halfway through an experiment to be able to do this and generate stuff, generate basically scripts that let you do this on top of a project. The part of this is also like the dummy data doesn't need to be entirely accurate. It certainly is helpful if you're trying to answer analytics questions, but if you're trying to do more like analytics engineering questions, the data can be a little bit nonsense and for its like analytical purposes. It doesn't need to be like the Airbnb data set doesn't have to have like addresses that make sense, for instance. They can just be stuff that looks sort of like an address and that's okay. And these like writing scripts that do that now is not terribly difficult. If you want to solve a problem that's a real world problem and give it like more analytics question, real data is a little bit more important there.
Yeah, definitely finding real data sources and then building DBT projects on top of them is one that is useful and valuable. I don't know. We've had this long-term dream of being able to build a script that allows you to kind of simulate an entire business across the board. And it feels like that's actually fully within the possibility space of existing models. If someone were to make a project of building a really great kind of business data set generator on top of DBT, I think that now actually like just with the most recent wave of models, we could get some really, really interesting stuff there.
Yeah, and I agree with that. That there is nothing has been done quite on that, but like we're getting close to that being a much more fun thing.
Robert sounds like he might be starting to tackle that very problem. Cool. I'm looking forward to that, Robert, and definitely would love to check out what you're working on. Cool. just scrolling through the questions. How do you generate the results tables? I keep seeing these, but I don't know how you guys are making that bed. My understanding of this is that this is a manual process at the moment.
What are the results tables?
Presumably, I think he's talking about just like the table that you share. That's like, here's how it does with Claude 4.5 Sonnet on Snowflake with Fusion.
Yeah, oh, gotcha. Like the scores. Yeah, that's a manual thing. There is it is not documented, but there is a couple utilities also that allow basically like when you run. I can just share this really quick and show some of the how this is all done. If you're here, there are ways basically like you end up running a bunch of these different sets because you're kind of experimenting with different things. You can save them. And so if I say, all right, save this, it basically will take this result set, save it into sometimes you have like draft director or like experiments like the one, this one's a demo and I don't actually want to save it. I don't want to persist it, but it persists in sort of a big folder or big directory. And then there's like a saved one where I can save it to particular solution sets. And so this is like my collection of results that I want to use for this particular score. And then there's scripts that allow me to like combine all of these scores together into one big directory. And then if I run something like this, it will allow me to basically open up that combined set into a DuckDB database. It'll generate all the things there. And I'm in the wrong place. I'm in the branch here. I don't want to do that. But let's see. Really winging this one.
We're in the after show now. We can do the riskier live demos.
Oh wait, I need to do. Let's see. Analyze. What is this? Demo webinar. I think it's webinar. All right. So in this case, it takes all the results from that webinar. There's a webinar experiment set, combines them all together, and then there's just like a query that combines them into these are the places where you saw the same scores. So that like the result table on the in the presentation was like a thing just in Google Sheets, but there's like a kind of 2 or 3 command pipeline that goes from running the experiments to producing a table like this that aggregates them all together.
Awesome. All right. I think this is a great question to close it on. So Omar asks, Goodhart's law is an adage that has been stated as when a measure becomes a target, it ceases to be a good measure. How do we avoid that trap when looking at benchmarks?
We don't really like. I would. This is probably a philosophical thing that lots of people who've thought about this much longer than I have probably have better answers for. My view of it is there is a point at which something like this no longer becomes that useful, and we have to create new targets, basically, that are things to figure out how good they are at solving these sorts of problems. You've already seen this to some degree with like software engineering benchmarks, where originally there was a ton of press every time a new model came out about how well they did on these benchmarks. They still push those, particularly for software engineering stuff, because that seems to be like places where like Claude and Gemini are really competing. But a lot of people are sort of starting to be like, these benchmarks aren't that helpful anymore. Like we need something else to measure them because should we be like, how long of a task can it complete or how much can it do? How far can it go before it needs human intervention or things like that? Because they're just like toy problems, can it solve it, are no longer as like representative of the differentiation between one model and the other. And so my view is like, if there becomes a point where you have a benchmark like this and the agents all solve it really well, then we have to figure out what it doesn't do well and create a new test for it that you don't avoid this kind of problem. But right now we don't have you have to get to a point where like the target becomes, or the benchmark becomes a target first. And we aren't at that point. And so like, I think that is progress. If this becomes, hey, we're really good at these sorts of things, what's next? In the same way the software engineering stuff has, but I don't think we can avoid that like kind of fundamental problem forever.
Yeah, that's right. It's just like a complicated space because on one hand, I think that there's a benchmark for simple math, and actually like having that be a target, because we all remember the days when the models would fail simple math problems, and now there's a simple math benchmark, and they just don't do that anymore. So to a certain extent, having a well understood benchmark that's part of the standard evaluation set can just help eliminate a whole class of problems. But on the other side, what we're seeing with a lot of the recent model releases is sometimes there could be something that shows a big leap in benchmarks, but might not actually be as big of a kind of hands-on usefulness leap. So I think we see this a lot with some of the smaller models, where a model will come out and it'll look great on the benchmarks, but then people try it in production and it turns out that it's really good at the benchmark, but it's not that good at the actual tasks that the benchmark was tracking towards. So this is benchmarks are an important part of the solution, as is all of us figuring out how to integrate these into our own workflows, building our own private test sets, so that we know what the models are good at, getting kind of an understanding of how the different models are progressing. There's a lot of work that needs to be done to make sense of all of this, and it's moving very quickly. So benchmarks are a really important piece of that infrastructure, but they're probably not the only infrastructure. And definitely we will need new and more benchmarks, as well as other ways of tracking and evaluating this as time goes on. Speaking of time, I do think that is all the time that we have here today. I want to say a huge shout out and thank you to everyone in the chat that stuck around for this. I want to thank Ben. This was a really kind of massive labor of love on Ben's part. It's a really great project, as well as all of the other ADE-bench contributors and the team at DBT Labs that helped put together this webinar and rolled with a bunch of technical hurdles. So thank you all. This was a real blast, and looking forward to doing this again soon.
Yep, and thanks, Gans.
All right, thanks and goodbye. Happy benchmarking.